Okay, let's give you guys another example. So we're going to use trigonometric substitution to integrate this. So to integrate this, our eyes should zoom into this complicated square root bit here, and then create a triangle in such a way that this statement is true. Well, if you look at this, if this is a b, then the hypotenuse would be a squared plus b squared. The hypotenuse would be this. But the thing is, we haven't got a plus here, we've got a negative here. So in order to create a triangle in such a way that this statement is true, we would need to do this. Set up in such a way that this is true. So if you set this to be a 3 and set this to be an x, then down here, then the adjacent here would be 3 squared minus x squared. Let's just say the angle here is theta. It could be anything. Let's just say it's theta. So now this triangle here will satisfy this complicated square root bit here. So now we can say, well, looking at this, set up your triangle like this. Okay, so from the triangle, so set your triangle to be this. Okay, so we are trying to integrate this. So when trying to integrate this, your eyes should zoom in to this bit here, and then create a triangle in such a way that this here is true. Well, create a triangle looking like this. Then later on we can set up your triangle to be like this. Now looking at this, looking at this, if you look at this here, this here is your sine. So sine the angle will be x over 3. Will be x over 3, and then if sine theta equals x over 3, then times both sides by 3, then x will be this. Then dx equals this thing here. Okay, and then now looking at this again. If you look at this, cos of theta will be this thing over 3. So cos of theta will be this thing over 3. And then times both sides by 3, then that will give you this. You see, now we've isolated our complicated bit here. So now we can put this into here. And then looking at this here, x squared will be 9 sine squared theta. We can then put this into the x squared, and then the dx here we can put it into here. Then everything will be much simpler. Okay, so put everything into here. Then this whole thing here will become this. Hang on, let me just. So this whole thing here. So this whole thing here will become this. Okay. So will become this, and then this will cancel out with this. So that will then give you this. Okay. So now something that you must already know. We need to integrate this. So to integrate this, we would put this into here. So that will then give us this. So now this thing here, you can factor out the half, and then this thing will become this thing here. So now integrate with respect to theta. So integrating it with respect to theta will give you this. Okay. So now our answer is in terms of theta, but we want it in terms of x. So we could from here. Well, we want everything in terms of theta. So we could do this here. If you look at this, we've got 2 times theta. We could do this. Currently we are here at the moment. Inverse sine equally. That would then give you theta equals inverse sine of x over 3. We could put this into here, but then when it comes to over here, we've got to remember our theta here equals this. So we've got to times this by 2, and then we've got to sine the whole thing. It looks really ugly. So let's rather than putting this inverse sine thing into here, timesing it by 2, and then sine the inverse sine, it will look really ugly. So from here, let's just use this to tidy it up. So whenever you have a double angle here, we can replace it with this. So put this thing into here, and then this whole thing here will then become this. Okay, and then tidy that up. It will then give you this. Okay, now let me think, please. So yeah, so tidy. Hang on, let me think. Hang on. Let me think. Hang on, let me think. Hang on, let me think. Yeah, that's right. Sorry. So now this thing here, you're timesing a fraction here, so it gets multiplied to the top. So the two 2's will cancel each other out. Then this thing here will become this. Okay. So this whole thing here will then become this, and then hang on. And then now we can now we can replace this. Earlier we said let cos be this, so we can put this into here, and sine we can put this into here. But here we would inverse sine equally to both sides. Then that would give us theta equals the inverse sine of x over 3, and then we can put this into the theta here. So earlier was really messy. If earlier we would have sine of an inverse sine, here it's slightly meter, it's just inverse sine. We can put it into here. So this whole thing here will then become this. And then tidy this up. It will then give you this. Okay.